Hi there. I'm going to talk about frequency distributions. Now, a frequency distribution is a table, chart, whatever you want to call it, that shows classes or intervals of data along with the count of the number of entries in each class, which is known as the frequency. Now, these distributions can be grouped as intervals, or they could be single number values, which we'll see here in a little bit. Now, these numbers I just made up. They're not based on any particular data, but we will look at one that has some data and show how to create one of these here shortly. Now, there's a couple of different ways you can see these things presented. If you know that your integers, data values will be integers, 3 to 7, and then you can start the next class from 8 to 12. So then we call each one of these the lower limit and the upper limit. So going from 3 to 7, 8 to 12, 13 to 17, and 18 to 22. Now that's fine if your data is integers. And because we would have what we call, because our classes need to be what's called non-overlapping, meaning we can't have a value fit in more than one place. But this wouldn't do us much good if we had decimal values, such as 7.5 or something like that. And so what the frequency numbers mean, that this, like I said, this data numbers I just totally made up, but that would have meant that in your data set, your list of numbers, you would have had 10 values that would have been somewhere between 3 and 7, 3, 4, 5, 6, and 7, 7 between 8 and 12, 5 between 13 and 17, and 12 between 18 and 22. Now, another way you might see these classes written is in this notation, 3 to less than 8, or I've also seen it as just 3 less than 8. This allows you to have values that have decimals. For example, you could have now 7.8 as a data value, and it would fit in that first class. Or 8.7. You can have values that are decimals. And then we have the same frequencies over here. I just use those as an example. So it could be written, two different ways. Depends on what your data is represented, how it's represented. All right, and that's what we're saying right here in this little box, that you can, that's a way to represent any real number value. And as I've also mentioned, that I chose those values. They did not represent anything in particular other than just an example to show what frequencies were. Now, a type of measurement that we need to know how to do from this is called class width. We need to be able to find that when asked. Now, class width is, you have to be careful when you measure this because it might not be what you think it is. The safest way to always measure it is vertically, the distance between the lower and upper limits. Now, it would seem logical if you looked at this first class here, and 3 to 7, you might think that that has a class width of 4. That seems logical, right? 7 minus 3 is 4. So that's not correct. It's actually 5. You measure it vertically, 3 to 8, 8 to 13, 13 to 18, and all of our distributions are based on also another premise, including non-overlapping, but equal class width. Now, you may run into frequency distributions down the road somewhere where you may see unequal ones, but we're only going to deal with equal widths here. Or even if you measure down the upper limit side, 7 to 12 is 5, 12 to 17 is 5. And same thing over here, 3 to 8, 8 to 13. Now this one though, you could measure horizontally, 3 to 8 on the right here. Yeah, you could argue that, okay, yeah, that is 5 from 3 to 8 going across. But just to be on the safe side, just measure it vertically every time, and you can never go wrong if you just measure it vertically. That's what I would recommend. And here you see I talk about that the class width for that example up there is 5. And we're going to use equal class widths. But like I said, you may encounter unequal ones when you look at other distributions you may see in other books and articles and things. Now let's look at the process and say we have a set of data, and we're not going to use large data classes on these because we're going to do them manually. So the first thing we want to do is decide on the number of classes or intervals that we want to include. Now there is a formula that actually involves logarithms to recommend the best number of classes, but I'm not going to worry about that. That will be a number that I would provide on any question. I would say, okay, we're going to have 4 classes or 6 classes, or you'll be told the number of classes for each problem. But like I said, there are ways to calculate it. The formula is kind of interesting. It has a logarithm in it, kind of a weird looking formula. Now here's the value that we're going to calculate, the class width. Now the class width, we're going to look at our data set. So like I said, you're not going to have maybe 30 numbers or so, 40 at the most. So it's not going to be that difficult. We need to find the maximum value, which is the largest number in that data set, and find the smallest value, which is the minimum. We subtract those two, then we divide by the number of classes that I provide. And this is very important right here. Round up to the next integer regardless of what the decimal is. This contradicts your standard rounding idea. Now, like once again, in real world, you could see maybe really round up to the nearest 100 or something. It depends on the size of the data values and that the numbers are really large. But we're not going to worry about that here. But we're going to strictly deal with smaller numbers and integers. So our rule is going to be we're going to round up to the nearest integer. So rounding up is very important. So let's say you calculate your class width and you get 7.2. We would have to round that up to 8. Now at this point you might be thinking, why do we have to do that? That's a good question. Because if you do not round up, what will happen is when you build your classes and start counting the frequencies, you're going to have that maximum value is not going to have a class to fit in at the end. So let's say, for example, your maximum value is 42 in that data set. And then when you construct these classes, that last value might end, the upper class limit of the last class might end at 40. Well, then we would have a problem because then 42 would have no home to go into. But if you round up, that guarantees that all values will be included. So very, very important here that we round up to the next integer. Now we're going to build each class interval. We're going to start the first class interval with the minimum value in your data set. Now that doesn't mean the very last one's going to end at the maximum value, kind of what I was mentioning before. It will most likely be a number a little bit larger than the maximum value. But that's good, because that way, as long as the maximum fits in there, that's all we care about. So we're going to start this at the lowest number, and then we're going to find the total frequency for each class. So what we do, like for example, using that one I had earlier from 3 to 7, we would literally go through our list of numbers and count how many of those numbers fit in that class. So that's why, needless to say, I'm not going to make this too difficult or tedious of a problem. I'm not going to give you some data set with 500 numbers and expect you to count it that way. Without the ability to use, if you used a software like Excel where you could sort it, then it'd be a lot easier. Now the statistics likes to use a lot of Greek letters. This first one we'll introduce is this sort of zigzag thing. That is called sigma, actually uppercase sigma. You don't need to know that that's sigma, but what this means in stats, and actually in all of mathematics, when you see that put in front of something, that means we're adding. Something's going to be added up here. So you put that, we're using the letter F for frequencies. So if you putting that summation symbol in front of the F means we're going to add the frequencies. Now we have something called, and you'll be able to see these a lot better when we construct the distribution here in a minute. But we have the relative frequency is kind of that's a percentage idea. It's divided by that sum of the frequencies. So in other words, let's say you had 30 total numbers, and 6 of them fit in a particular class. Well, your relative frequency would then be 6 over 30, which, you know, could be expressed as a decimal, 0.2. Sometimes they're fractions, sometimes they're decimals, sometimes they're percent. It won't be hard to figure out what you need to use for any particular problem. Being multiple choice, you'll be able to pick the you'll see the right format you're looking for. But yeah, so 6 out of 30, that as a fraction is 1/5. As a decimal, it's 0.2. As a percentage, it's 20%. So it can be expressed any way like that. And it's sort of like a probability in the sense that that would mean if you were going to randomly pull a number out of your list, you would have a 20% chance that you pull that value out. Now, cumulative frequency, that'll be a little bit easier for me to explain when we see it in action here in a minute. But you're basically, it's like you're keeping a running total. It adds up everything in that particular class plus all numbers before that class. So we'll take a look at that when we build it here now. So here is just a list of, and I believe that's 30 numbers. And we're going to build a frequency distribution, and notice my instructions say 4 classes. So as I mentioned before, that is a number that's provided for you. We're going to construct that into 4 classes. And so what I need to do is go through here and find the minimum value. I'm looking at 2 right there. And the largest one right here is 35. So 35 is the largest, 2 is the smallest. And so then we take 35 minus 2 divided by 4. That gives me 8.25, but what did we learn earlier that I put in big red letters? Round up. That means our frequency will be 9. Class width will be 9, excuse me, not frequency, class width. So I'm going to show you, now I wrote both ways, you know, how to set these classes up. You probably wouldn't see both of these on a test question. It could be this less than rule, but more likely it'll probably be, well, this certainly, since it has integer data here, you can, both ways would work here. You know, there's you don't have any values like between 10 and 11, you know, that would not fit in there and that sort of thing. So, all right, I started with 2. Now we learned a little while ago how to measure class width. So it doesn't go from 2 to 11 across, it goes 2 to 11 down. So the way I like to do this, I'll just start with 2. I'll add 9 to write 11 there. And then I'll add 9 to make 20. And then because we were told 4 classes, 1 more is 29. And then I know if this one started at 11, that means the first one had to end at 10. Unless you're using that less than format, then it would end at 11. But that one ends at 10. So I can then add 9 down this way. So 10 plus 9 is 19, plus 9 is 28, plus 9 is 37. So there our classes are now built. So notice here's why the rounding up was important, because our largest value is 35, and it now has a place to go, doesn't it? If we had rounded down, probably would have finished at about 33, I'm guessing. Then 35 would have been too large for that interval. So that takes care of the classes. Now the frequency. So all you have to do is go back up here and follow the bouncing ball here. It's not difficult to do this, but when I've done these in class, I've made mistakes because I'm trying to talk and do it. You know, it's sort of the same thing here, I guess. But you know, it's not difficult concept, but it's easy for your eyes to not see a number, that sort of thing. So I'm looking for anything between 2 and 10. There's 1, 2, 3, 4, 5, 6, next row, 7, 8, 9, 10, 11, and 12. And then there's the frequency, 12. So that means there were 12 items between 2 and 10. Now, I'll do 11 through 19, then I'll go ahead and move on, assuming you'll probably get the idea. You probably already have the idea by now. But let me go ahead and do from 11 to 19. I'll count one more time. That'll fit. 17. 1, 2, 3, 4, 5, 6, 7, and 17 at the end, next to the end makes 8. 8 of them, so you see. So then you do all those, and it's a good idea then to add up your sum of your frequencies. So that's not a bad idea. So 30 is that total. I'll just kind of I'm using a mouse pad here. This laptop doesn't have a writing ability, so I was going to try to draw the zigzag there, but that's okay. It'll probably be too much trouble. I was going to write this. I'll show you what I was going to write next to that 30. I was going to write this right here. The sum, the sigma f thing equals 30. Not that was mandatory, but just to show you that notation. So that's so it adds up to 30. Now, one thing about this is obviously, if it adds up to 30, that doesn't mean it's done correctly. This one is done correctly, but one thing to keep in mind, like I was talking about how your eyes can get fooled by this. Certainly, if it adds up to something like 29 or 31, then you know it's wrong. You can go back and try to check and figure out where you messed up. Now, midpoint, we use that for something a little bit later, but let me go ahead and tell you what it is. And we'll only use midpoint for formats that are written in the first way, where it doesn't have that less than. I won't use midpoint other than that. But for this one, the midpoint, basically the midpoint is the average of the two class limits for each class. So the midpoint between 2 and 10 would be 6. 6 is right, and then you see I wrote across the top for that one. 2 plus 10 divided by 2 equals 6. Now then you can do the same thing for the rest of them, but here's a little trick. In other words, 11 plus 19 is 30 divided by 2 is 15. But another way you can do it is, if the class width is 9, which it is, and if both ends of the intervals, are increasing by 9, that would mean the midpoint would have to increase by 9. So you can start with that 6 and just add 9, just like you could back over in the classes. 6 plus 9 is 15, plus 9 is 24, plus 9 is 33. And then here are the relative frequencies. I didn't bother to, I know the fractions could be reduced and all that kind of stuff. I didn't worry about doing that. I just wanted you to see it unreduced. It's not that critical. Like I said, you'll be able to look at answers and figure out what format they're in and that sort of thing. But the relative frequency is not too difficult. It's just you just take each number in your frequency column right there and divide it by 30. Just write it as a fraction. So 12 is 12 over 30. 8 would be 8 over 30. So forth, so on. Left a dot there. All right. Cumulative frequency. Yeah, now let's talk about that. And you can even do cumulative relative frequency. I never really asked that, but you could also do that. Cumulative frequency means you take what's in the whatever class you're in, added to the frequencies for every class before that one. So for the first one, it's going to be whatever's in your first class because there's nothing before it. So 12 will be 12. Now 20 represents, for the second class, means the second class plus the first class added together. 12 plus 8 makes 20. Now the next one's 26. So what you could actually keep doing in the cumulative frequency is start with your number like here, 20, and then add the next class. So 20 plus 6 in the next class makes 26, and then 26 plus 4 equals 30. So just like the total of the frequencies add up to 30, you don't add these cumulative frequencies, but the last number in the cumulative, though, is going to be your total frequencies. It's going to be at 30, because when you're in that last class, you're adding up every class before it. Now, what the class boundaries are going to help us with a particular type of graph that we're doing here below. But let me explain that. Once again, I'm using the format for the first column of the classes, not the second column. For the class boundaries, all you do is we're basically increasing the width of the class. And this time we do want them to connect. So that 10.5 does connect with the other 10.5. That's okay that it does that for this. So basically you're taking every number in the left column, 2, 11, 20, and 29, and you're subtracting 0.5. So 2 minus 0.5 is 1.5, 11 minus 0.5 is 10.5. In the second column, you're taking 10 and adding 0.5. So in everything in the right column, you're just tacking on 0.5 at the end of it. So those are our connect. I have that explained in words right here. I'll just leave that part right there. And that's going to help us draw this type of graph for this section. Call it a frequency histogram. It's a special type of bar graph, and we're going to see other bar graphs that don't necessarily have to connect. It's quantitative. It applies only to quantitative data. If you go back and look at that list of terms and definitions that I provided in the notes, let me just kind of scroll down here and go and tell you what those two are right now. There's other ones in that list too that are a good idea to know that could show up on the first test. But I just want to mention that quantitative data is data whose measurements are numerical. Anything where the result would be a numerical measure, how many courses are you taking this semester? Things like that, where your answer would be a number. Qualitative data is data whose measurement scale is categorical. You would have a word type response that was non-numerical. Someone asked you, what's your favorite color? That would be qualitative data. What is your major? Qualitative data, non-numerical. All right, so you can see those on that list. Because in other words, there's going to be bar graphs that we can use for qualitative data also. But this special bar graph is only for quantitative data. It's got to be numerical. So what we drew here is, now on the y-axis you can have frequency or you can have relative frequency. The bar shapes would still look the same. So I've seen people do it both ways with frequency and relative frequency. It would still give you the same visual idea. So what you do is, and on the x-axis you now put the class boundaries in there, and also put the midpoints in there just to show you the midpoints right in the middle. So you see because that way it's going to allow these bars to connect. So you go 1.5 to 10.5, and then we had 10.5 to 19.5, and then to 28.5, and then 37.5, which is from right back up here, those class boundaries. So then we use the frequencies. And this is wrong for this problem. I just realized I must have changed the numbers a little bit. So let me see if I can, without a writing pen, this is going to be difficult to fix, but because your height goes up to the frequency. I must have used another problem and didn't change this. So 12 means my bar should have a height of 12. So let me just and I can fix this before I actually post the written file. So this will not look very good, but I want it to at least be correct anyway for now. So we would kind of go up to here a little bit, over and down. Not good, but not the worst I've ever done, I'm sure. And then this would now say 12. Because that represents the height of that first class. Yikes. Now the next one is 8. So I need to lower this one. Okay. Go and erase that off a little bit. Okay, let's erase that a little bit and just kind of come over here. I don't really have to be writing the numbers above it, but went too far, but that's okay. Like I said, I'm going to clean this up before I repost this file. And there's a terrible looking 8. And then the next one is 6 and then 4. Those are still correct. So you see between 19.5 and 28.5 has a height of 6, and the last one has a height of 4. That's a histogram. Now this one doesn't tell too much because it's just a small number of values. But what we're looking for here, and that's what all these displays and graphs and that we're going to see in the next section are dealing with. It's taking data, and a lot of cases large numbers of data, to present them in a more visually appealing way to look at it. And sometimes you can have, and we'll talk about this later too, is you might see bars heavier to one side than the other. You can look for trends. Oh, we see maybe some of them. This one's, I don't know, just sort of a stair step, not very good, but you can look at it and say that it is heavier toward the lower side of the numbers here. So you're just looking for anything that would sort of give you, any kind of indication, and that way you can make any statements about the data or anything like that. So, anything would be better than looking just a giant sheet of numbers with nothing more than that. That really wouldn't tell you much. But graphs are helped to display data in a more friendly, user-friendly manner. All right. Now, I mentioned earlier you can have a frequency distribution based on single values and not classes. So I then also did the histogram with this. I totally just once again I just made these numbers up. I didn't really survey 50 students, and asked them how many courses they were taking. So X represents a number of courses, 1, 2, 3, or 4. Those were their answers. And with 1, 2, 3, and 4, that'd be kind of, I think, silly to put those in intervals. So I just said 6 of them said 1, 16 said 2, 23 said 3, and 5 said 4. Now I didn't, I made those numbers up, but it is very important though that those numbers added up to that 50 right there. That's important, obviously. So I can't make up frequencies and then have them not add up to the total. And these 4 numbers do add up to 50. So that's good. So here's now I did the class boundaries for this one, which I don't think are really necessary. I did them right over here where I just kind of, this one, I know it's different than the way I explained it before, but here you're just taking that one, only that one right there, and then subtracting 0.5 to it and adding 0.5 to it, same number. But anyway, the easiest way to kind of think of this on looking at the histogram is just, when it's a single number distribution like this, it's just the number will go right in the middle of the bar instead of the 2 endpoints. So you see how I have 1, 2, 3, and 4 centered in the middle of the bars, and that's going to allow the bars to connect. So I came over here, then you look at the frequencies, and then so you have 6 for the first one, so has a height of 6, and then 16 is the next height, 23, bars all connect, and then 5. All right. So that concludes frequency distributions.